In question 1, we'll compute these 4 logarithms, starting with log base 4 of 16. Whatever this is equal to, I'll call it x for now. 4 to the power of x should be equal to 16. So that's what this logarithm means. What do you put in the exponent of 4 so you get 16 back? And if you square 4, you get 16, so the answer is 2. Now for the next one in B, log base 9 of 1 over 81. So whatever the answer is, 9 to that power equals 1 over 81. Okay, so in this case, I see a fraction, so I'm already thinking a negative number. And I know that 9 squared is equal to 81, so therefore 9 to the negative 2 is equal to 1 over 81. This means that the answer is negative 2. All right, what about log of 1,000? Now, it's not written, but this is log base 10. So this means the same thing. Okay, so for this one, I like to think about log base 10 as counting the number of zeros. So I know the answer here is going to be 3. But the reason for this is 10 to the power of 3 is equal to 1,000. And for this last one, log base 6 of 1. So 6 to some power should be equal to 1. And well, I know anything to the 0 power is 1. Therefore, the answer is 0. So these are the answers to these 4 logarithms. In question 2, we'll expand these expressions using the properties of logarithms. Starting with A, log base 5 of 125 times the variable z. Well, if you have a product, that can be re-expressed as a sum. All right. Can we simplify this any further? And it looks like we can. Log base 5 of 125. What is that? So let's see here. 5 to some power, does that equal 125? Does it reduce down to an integer? And it does. I know if you cube 5, you get 125. Therefore, the simplified answer is 3 plus log base 5 of the variable c. Okay, for part B, lots going on in this one. I see a fraction, and then it looks like there's a product in this numerator, and then I have a square root in the denominator. My first thought for this simplifying this is to write it as the natural log of e times y squared minus the natural log of the square root of x. Now, I have a product here, and just like in part A, I can split this up into a sum of the natural log of e and the natural log of y squared. But also note that if you have a square root or any type of root, it's an exponent. That's a fraction. So I'm going to do 2 steps at once here. I'm going to break this up as a sum, and I'm going to rewrite this so it's x to the 1/2 power. So first we have the natural log of e plus the natural log of y squared minus the natural log of really x to the 1/2. So there's no property of logarithm here. This is the definition of a square root in terms of an exponent. Let's see. Oh, the natural log of e. Well, the natural log is log base e, so kind of off to the side here. ln of e, that means log base e of e. And therefore, this thing simplifies to 1. And the reason for that is e to some power is equal to e, and, well, that number is 1. So here we have 1 plus, now I'm seeing in this next piece here, I have this exponent of 2, and there's a property of logarithms that says that 2 can come down front. So I'm going to write this as 2 natural log of y. And likewise, I see another power that I can bring down to the front of the logarithm, and I can write this as 1/2 the natural log of x. This cannot be simplified any further, and this is the final answer. In question 3, I want to sketch a graph of 2 to the x plus 5 plus 3. To start with, I'm going to sketch a graph of y is equal to 2 to the x. If I have this here, I can use transformations to get this graph because the x plus 5 means we're changing the x values. So we're going to go left 5. And the plus 3 is changing the y values. So we're going to go up 3. So if you graph 2 to the x, let's see, at 0 it's equal to 1. At 1 it's equal to 2. At 2 it's equal to 4. And at 3 it's equal to 8. Maybe I'll put in here that at -1 it's equal to a half. So the graph looks like this. And it's worth noting that it has a horizontal asymptote at y is equal to 0. All right, so if we actually want to sketch this function, I'm going to move these points through these steps. So starting with maybe this one here, at 0, 1, we go left 5, and then we go up 3. So that point is now here at -5, 4. Okay, at this point, if we go left 5, we're at -4. And if we go up 3, we're here at -4, 5. Okay, at this point, if we go left 5 and then up 3, we're here. And I think a couple more. So this one, if we go left 5 and then up 3, we're here. And then this one too, I know it'll go left 5 and up 3 to right about there. So the graph that goes through it will look like this. And then it levels off here. So it's a very rough sketch, but there it is. That's the graph of 2 to the x plus 5 plus 3. Now, where's the horizontal asymptote of this function? Well, if the original one is at y is equal to 0, left 5 doesn't change it, but if you go up 3, it'll be here at y is equal to 3. As for the domain of this function, it's going to be all real numbers. But the range is everything that's above the horizontal asymptote, so that's from 3 to infinity.